Welcome to another video on SPC 229 schema. This is your Vice Chair, Jason Glazer. Today we are covering data groups for FAN Output Validation Point, and Terminal. As you probably remember, for the first week after the video is posted, we encourage discussion by email on any issue found. Hopefully, all issues will be identified during this week. After that, we will have a letter ballot, which will also last 1 week. If minor issues were raised during the discussion, they will be included in the letter ballot, but if it's something more complicated, it will be referred back to the schema working group and will be brought up again in a future ballot. Today's video is the last of the 3 videos covering air side of HVAC. The last 2 videos covered heating, ventilation, and air conditioning system, heating system, cooling system, fan system, air economizer, and air energy recovery. This week we'll be finishing up air side with FAN Output Validation Point, and Terminal. As I've mentioned before, air side, while being as complex as water side, does not break into various real-world components as easily. I hope everyone will appreciate that there is no right answer, but instead we'll just try to be making sure that the proposed approach is a workable solution. Remember that the schema is intended to aid in validating that the transformation between the user's model and the baseline model is done correctly, and is not intended to be a universal model of everything that can appear in a building or be modeled by a simulation program. So, just to remind everyone, a building segment is part of a building. So there's a bunch of building segments in a building. And 2 of the children of building segment are zone and heating, ventilation, and air conditioning system. One of the things that is a child of zone is terminal, which we'll be covering today. And that points to heating, ventilation, and air conditioning system. And then terminal and fan system point to fan. And fan itself points to fan validate, or has a child, a fan output validation point. So that's how all the pieces are connected, and we'll be diving into it a little bit more now. So the first thing we want to cover is fan. So, like all the other data groups, FAN has an ID, reporting name, and notes. And then it goes through several other inputs, mostly related to how a design of a fan would work. So the first is the design airflow, which is a number. And then the specification method, which is an enumeration for fan specification method options. Now that enumeration really only has 2 options. One is simple and the other is detailed. So if you go with the simple approach, then you enter the design electric power as another numeric value in this data group. If you're using the detailed method instead, you enter a bunch more values having to do with how a fan is typically specified, including the design pressure rise, the nameplate power, the input power, the total efficiency, and the motor efficiency. Now, the input power specifically is the power delivered to the fan's shaft, so it's basically the brake horsepower is what's typically considered. After that are 3 fields having to do with how the heat is dispersed from the motor itself. So the first is motor heat to airflow fraction, and then there's a motor heat to zone fraction. These don't necessarily add up to 1. They can, but they don't necessarily have to. So the first one is how much heat from the fan goes into the airflow. So if the fan is completely mounted in the airflow, I think it's usually common to just say 100% of the fan heat goes to the airflow. Likewise, if a fan is mounted and with a belt-driven motor, where the motor itself is outside of the duct, that is more likely to have a motor heat going to the local zone wherever that fan motor is located, and very little heat going to the airflow fraction. So if you specify any number for the zone that the motor heat goes to, then you also should specify the motor location zone. So that would be a reference to the zone that has the motor. The next thing is status type, which we'll talk about in a little while. It's an enumeration. And then a reference to this output validation points, which is the next data group we're going to be talking about. So let's first talk about those couple of, well, I guess we pretty much covered the fan specification method enumeration. Let me show it to you. So it's simple and detailed. And then the other enumeration is actually a Title 24 specific enumeration. These are general status enumerations. You'll see it throughout the schema. And it basically has to do whether the component is new, altered, existing, or existing plus new. So these are specific terms used for within Title 24 to describe the condition of that particular component. So getting back to the schema, the next thing to talk about is output validation point. So unlike most of the other data groups, it does not have an ID, reporting name, and notes. And that's because we're expecting that that people will use a series of these regularly to specify the airflow and basically the power related to it. So there's a pairing of these two numbers that will go along and be able to be used to validate when a fan power curve essentially has been specified correctly. So in 90.1, there's this table that you might be familiar with that talks about the part load ratio on the fan and the fraction of full load power. So basically, these are both described as fractions, whereas in the schema, we're actually looking for hard values, but you get the idea of what this is about. So the next item is terminal. The next data group is terminal. Now, if you remember, the zone includes a terminal, and this points to a fan. So again, it has an ID, reporting name, and notes. And then it has a type, and I'm going to talk about that a little bit more because it's such an important aspect of what the terminal data group is. So the options for type here are variable air volume, constant air volume, which you'd expect for a terminal. But in the case of terminal, it actually means more than that in the parlance of this schema. It also can include radiant and baseboard. So basically anything that provides heating and cooling into the zone could be described as a terminal, but in these specific areas, it's these items. And let me read the note to you because it's pretty important. So it says, system configurations typically are at the zone and include a compressor, such as package terminal or air conditioning or package terminal heat pumps, window air conditioners, and water loop heat pumps, should be modeled in the schema using a heating system and cooling system. Systems that include gas or electric furnaces should be reported in the schema using heating system or cooling heating system. System configurations that are at the zone only and include fans and coils, such as 4-pipe fan coil, 2-pipe fan coil, radiant systems, baseboards, and chilled beams, should be reported in the schema using terminal, but their central components for chilled water and hot water systems should be described in the heating and cooling systems. Evaporative cooling systems should be described in the cooling system. Passive diffusers with no coil or fan should be described in terminal. So this is a note to clarify how things should be described. So keeping going from that are 4 fields, one having to do with, basically having to do with, 5 fields. The first one has to do with what heating and ventilation air conditioning system is referenced. So this is an ID of the heating, ventilation, and air conditioning system that the terminal would have. And then heating source and cooling source are basically pointing to loops. So in the case of a baseboard, for example, the heating source would be pointing to a heating loop. That's the heating from loop and cooling from loop fields. The heating source and cooling source are actually enumerations describing that. And we'll be talking about that in a minute. The next thing is a fan and fan configuration. The fan is actually pointing to the child data group of a fan. And then the fan configuration is a enumeration. Then there's a primary airflow and secondary airflow, terms that are familiar to those with knowledge of VAV systems. A supply set point temperature. A temperature control enumeration, which we'll talk about in a minute. Minimum airflow and minimum outdoor airflow, and a minimum outdoor airflow schedule multiplier. So the first two are just numbers having to do with the minimum airflow and outdoor airflow. And the third is a multiplier on that outdoor airflow. And then we have a heating and cooling capacity. And that's the capacity only of the component at the terminal. And then there's 2 Booleans. One is called is supply ducted, which has to do with whether there's ducting for the supply. So a package terminal air conditioner, package terminal heat pump, and window or through the wall units would be false for this. And then other DX systems that have ducts would be a true. And then there's the last field here is has demand controlled ventilation, and that's true or false. It's a Boolean. So let me go through those enumerations a little bit more. So the first one is terminal options. As I said, it's these 4 things plus other. And then there's a terminal fan configuration, which, not surprisingly, is parallel or series or other. Terminal temperature control options has, this is how the terminal would be controlled. So for many terminals, it's constant. But there might be a load reset differential temperature type of control, or it might be a scheduled control. And then heating source options and cooling source options. For heating, there's electric or hot water, none, or other. So if the terminal has no heating, you'd specify none, for example. And then for cooling source options, there's chilled water, none, and other. So that's all we're covering today. Thanks for watching the video. As a reminder, if you have any questions or comments on the schema, please just reply to everyone with your comment, and hopefully it can be resolved as part of the ballot. About a week after this video is released, you should be receiving a letter ballot from ASHRAE to vote on this. Thank you.